Good morning. Welcome in this session on modern OpenVMS system management. It's a session where I'm going to tell you everything about the product. Can't he come in? Oh. You always wanted.
Thank you.
I'm going to tell you everything you always wanted to know about a product called CockpitMgr for OpenVMS. Okay, let me introduce myself first. I'm Johan Michiels. I'm living in Bruges in Belgium. I'm 42 years on OpenVMS. I started in '83. And 32 years of this, I worked at Digital Compact HP. 32 exciting years with a lot of highlights. I started in support, then I did some applications programming for customers. I became manager of TechTown, which was our demo and benchmark center in Brussels. And after that, I became a consultant, mainly specialized in OpenVMS system management, architecting, multi-site, disaster tolerant clusters, centralized monitoring, automated operations. I also did a lot of migrations from VAX to Alpha, from Alpha to Integrity, from HP to VSI, and we are ready actually to do migrations to x86. I launched that product, CockpitMgr, in the early 90s, and I like to start and take a bit of time to tell you why we started and what we are doing with CockpitMgr, especially why we started. So let's begin with some history. In '93, Digital launched Polycenter. Polycenter is not a product, it was a marketing umbrella. At that time, Digital developed quite a number of products. They had products already on sale since the late 80s, I think, but they were not selling very well. So they wanted to give some push, and they renamed everything to Polycenter something. And a whole bunch of Polycenter solutions for system management, problem management, performance, storage, automation, network, everything. And they made a good marketing thing. They delivered nice catalogs. That's the version of 93, 94, 95. And they did the work pretty well. What can we say about the products? Excellent products. People love them. Excellent from management of standalone systems and systems we had clustered in the CI or PSSI environment. And storage quite locally attached with HS controllers. People loved it. I sold quite a lot of Polycenter licenses. Correction, I sold a lot of Polycenter licenses in combination with consulting, because we did the job internally as a system manager, TechTown manager, without the products, and we added already some new tools to them. For instance, an automatic repair, a fast configuration of the system watchdog, some scan profiles for the console manager. So we built up some technical luggage, and with that we could go to customers and we worked with them, and they worked very quickly on speed with Polycenter. Unfortunately, the products remained point solutions. There was no integration between the different products, and everything came with its own configuration utility and its own notification utility. So they remained point solutions. In the meantime, also the technology and customer demands are changing. To name a few, I installed the first multi-site disaster tolerant clusters in '95. That was with FDDI, the Giga switch, things like that. That means that the network becomes part of your cluster, so you need to monitor your cluster. We could use TechMCC, later renamed the Polycenter framework for that. That was a beast, very difficult to configure, uses a lot of resources and things like that. It was the first Polycenter product that was removed from the list. Anyway, there was no internet when Polycenter came out. Can you imagine a product that does not support something with a web browser today? Well, there was nothing. There was no web browser. There was nothing for alerting via the web browser. And the corporate desktop became popular with Windows NT. That was after 96, 97. I mentioned XML. The standard was made also mid of the 90s because I'm going to use later in my presentation also XML. They can convert XML files to HTML with the XSLT utilities. There was no cell phone. We developed something to send messages to someone's pager, classic pager everybody was carrying, and you get a number or some text. It's obvious that when the cell phone came up, mid of the 90s, that we want to text messages to cell phones. At the end of the 90s, we had fiber channel. Suddenly, the storage was drifting away from the systems, and we had to monitor that storage network, right? SSH started the first specs for SSH mid of the 90s as well. So everything came just after the release of Polycenter. But at the time, nothing happened. There were maybe some bug fixes, but nothing was added in functionality to the products. And then the real showstopper. In 96, CA, Computer Associates, acquired Polycenter. It was the time that digital was selling everything off. RDB, DBMS, CDD went to Oracle. The middleware went to BIA. And BIA was later acquired by Oracle as well. The printers went to Genicom. The network devices went to Cabletron. And Polycenter went to CA. I must say customers were shocked. They like to work with digital, they like to work with us. We had a very good relationship. We were speeding up the functionality they needed. And the result was that at that time in 96, I was ready with the rewrite of System Watchdog. I made a system monitor myself with extra functionality that was missing in System Watchdog. I will tell you later on more details on that. And I also did SNMP stuff to monitor the FDDI, the network for my cluster. So what customers said, Johan, you're doing well. We don't like to move to CA. You do a little bit more and we stick to your solution and we will keep our Polycenter products from digital. We are not going to move to CA. CA was actually mainly interested in pushing Unicenter. They were not that interested in Polycenter. They wanted to sell Unicenter to the people. So we decided then to build a new fully integrated solution on VMS for the VMS systems. And our idea was we are going to develop a dedicated system that will take care of everything. Consoles, systems, network, storage, security, log files, formats, and so on. Okay. The dedicated system, we call it the cockpit, runs on VMS. I think a VMS system manager works the best on a VMS system. Don't have to agree with me, but that's my opinion. So that was the idea. Today, I believe Cockpit Manager evolved to the most complete solution on the market. I want to prove this to you, that's for sure. If somebody says at the end of the presentation, that's what's right, and now something else that is better, stand up and talk. It's a product created by VMS system managers for VMS system managers. It's not only my experience, my expertise in there. Once I was a consultant, I was nearly every day with the customer. In those 20 years afterwards, it got reduced due to the COVID. And it didn't go every day anymore to customers. So what I learned there for my customers, that's all implemented in one product. So we are still enhancing. There are 2 new features that I will announce today that will come in the next release. And the product is utilized by many serious customers using VMS in a mission critical environment today. That's to explain a bit why we started with it and what we are doing. Okay, so now I can give you an overview, a more technical overview of the features. We're first going to talk about monitoring. There are 3 base components: console manager, system monitor, and the network and storage monitoring with SNMP. We have other utilities that generate events. Then what we monitor needs to be notified, of course. So all our monitoring results will pass through an event engine, which will prepare all the stuff for notification. We integrate with tools in the enterprise, and then we also have a number of utilities like the job scheduler census, which is for configuration and change management, NetDCL, and a new backup solution. Okay, let's start with the 3 base components of monitoring. Before that, 2 definitions. The first line I didn't invent myself. I found it somewhere in Wikipedia, somewhere on the network. Monitoring is the continuous and systematic observation of the health and performance of IT services and their underlying infrastructure. So we want to monitor continuously everything and really systematic. The system manager shouldn't come in the morning and say, what I'm going to monitor today. Well, the system must do the work for you continuously. The goal, obvious, we like to beat the phone call. You should never receive a call from an end user to say something is not working. You need to know this yourself. You need to solve issues before they really become critical. Monitoring can be either active and passive. Active, you poll the services. Passive is that the device sends you notification or alerts. The second definition I made myself. Every piece of information received by monitor will be categorized as an event. And an event has multiple attributes. There are 11 things, and keep that in mind because that will come back multiple times. The system will give it a unique number. There will be a system or a cluster name assigned to it. There's a subsystem, that's the item to which the event relates. It can be process name, a disk, a shadow set, queue. There's a name for the event. There is a class that makes filtering easy. Later on, I will show you examples of that. There's a message text, a priority or severity level, critical, major, minor, and so on. A timestamp, a source, which application created that event. There's an owner and a solution, sometimes. An example, you find a process ABC is missing on node prot 1. You can read for yourself. You have a sequence number. The system is prot 1. The subsystem is ABC. And the name is process missing. With these 3 items, basically you know already everything on the event. Assigned class system, the text process ABC is missing. It's a critical event, timestamp, and the source. Okay, let's start with the console manager. Who worked on faxes? That's the system where I started in '83, the fax 780, with 4 megabytes of internal memory. You won't believe that. And we were developing software with 20 people, such a machine. And we had for the console either such a paper writer or tech writer. I don't know what it's called exactly. So that was the console with paper to log everything. Later we could connect the VT100 to it with sometimes a printer behind to capture all console messages. That was the early days. So if you need to boot or shut down your system, do an upgrade, do an installation, do hardware diagnostics and things like that, you had to go to the cold computer room. Okay? So what do we do? What did engineering do I think at the end of the 80s? That's the situation. VAX, Alpha at the time. Digital released the DEC server, the terminal server, and that was mainly to put in the offices, and everybody could plug the terminal on which he was working, and he could connect to the systems with LATs or Telnet protocol. The terminal service can use also to connect the console line to it. So the terminal goes away and we replace it by a terminal server. Goes on the network, and then you have a VMS system. I already call it cockpit with console manager software. Okay, that makes it possible. First of all, connect to the console and do all the work you need to do. So wherever you are in the world, you can log in on that system. You can reach the consoles. That's the first practical feature. Second, important is that everything that you send, that you read on the console, can be captured and stored on disk. Okay. The third functionality, and from the point of view of the operations, the most important functionality, is you can scan console outputs for text strings or text patterns. Get a message, fatal bug check. Want to know immediately, right? Or lost connection to system, the connection manager. These things you need to capture and see immediately in the cockpit. So we developed a new console manager with the three functions: the connection to remote systems, the logging, and the searching, the scanning of the console outputs. We came with many scan profiles for a whole bunch of things. Pre-prepared events where the consoles can scan for. The first releases of Console Manager came with nothing, virtually nothing. So that's what we did. A little word on terminal servers. Okay, we did this for VMS consoles, but you can connect the consoles of any device into Console Manager. I have a customer with over 3,000 devices configured in his Console Manager. Can you imagine? All his network switches, all his storage devices, everything is configured in the Console Manager. The DEC server is gone. You still see them once in a while with customers, but it's end of life for a long time already. It only supports 10 megabit half duplex connections. Modern switches don't like that anymore. They don't support that anymore. And there is no SSH, only LAT and Telnet. So we found two new terminal servers, one from Perle and one from Digi. And I show you later on the pictures of these devices that support both Telnet and SSH, and we support them. Okay. You don't need a terminal server if you like to monitor console of integrity. We have the management processor. You can connect with SSH and Telnet to it. If you have emulated faxes and alphas, not necessary to have a terminal server because there's an IP port to connect to. On x86, we'll see where we end up. For the moment, I only have a Telnet connection to my VMware instance of x86. We'll see what will come in the future. So the two pictures with Perle and the Digi terminal servers. Okay, the first module I actually rewrote was the system monitor. But I rewrote it in the same way, but with quite a number of differences. So it's the system monitor that runs on the cockpit, talks to agents on the different VMS systems. What you will monitor, you define on the cockpit. So on the agent, basically you only need to say, I accept connections from this cockpit and from nobody else. There must be some protection in there. Connection, TechNet, IP, SSL, it all works, all supported. Basically, you create with a command line utility configuration files, and you can create multiple configuration files, and with each configuration file, you will monitor a number of systems and clusters. You don't have to put everything in one file. So the picture looks as follows. There is you, the system manager, creating a config file for production, for instance, for QA, for development. So each file contains a number of systems, clusters. Usually you put one cluster and the members in it, but you're free to do whatever you like there. For each file, an instance of the system monitor is started, and each system monitor talks to the agents on the different systems through TechNet, through IP, through SSL. Okay? QA, two systems, and the development is one system. Okay? So in summary, the command line utility, config files, one instance per config file, talking to the agents. Right? Picture is clear? No problems, no questions? Good. What is monitored? Well, the standard things. System accessibility. Okay, we make connections every minute to the agent, so we know that the network works, that the system is reachable. Changes in the hardware error counts. Time difference. Recently, I had a system where NTP was not well configured and the clock was drifting. So I got notification that my difference in time between the cockpit and the system was incorrect, was becoming too big. We monitor processes on one system, or processes that must exist cluster-wide. A process is normally defined by a name and the UIC. UIC can be optional. You can specify wildcards in the process names. Okay? And if you specify a wildcard, in that case, you can say, I need minimum so many occurrences of that process on my system. Disk free space, disk state, high watermarking must be enabled or must be disabled, or I don't care. Three options are there. Same thing for erase and delete. Shadow sets. Is a disk missing as member of my shadow set? Or the copy and merge operations going on? Is there a disk unexpected member of shadow set? Somebody could have done a mount of a disk, but in the wrong shadow set. So you get a message then as well. State of queues, the queue manager, the status of batch and print queues, and the number of pending jobs on a batch queue. That can also indicate a problem when too many pending jobs are waiting for execution. We monitor batch jobs. You can specify name, user, queue, parameters for each batch job. If you have a generic queue with multiple execution queues, then you specify the generic queue. Even when the job is executing on one of the execution queues, it will be considered as okay. Now, what's the big difference with Watchdog? First of all, we can monitor each item to specific times of the week. If you stop every day at 8 o'clock in the evening your application to make a backup, you don't want at 8:01 a message on your cell phone, hey, there's a process missing. Okay, so you can exactly say from which hour to which hour during the day, during the week, something must be monitored. Items can be checked node and or cluster-wide. You can specify wildcards. There's also a quick configuration utility. So there's a utility that scans a node, takes into account what's already configured, subtract both things, and generates all the commands of the things that are not yet monitored. And then it's up to you to take from that file and put in the configuration tool. You can define automatic repair utilities. And now I hear you say, yeah, but I spent so many time to develop my own little monitor for my application very specifically and so on and so on. Then we can easily integrate that with the agents. You can develop your own extensions. There is an API for that. There is a DCL command for that. You can feed in events into the agent, and the agent will relay it to the cockpit, to the system monitor. There's functionality to add, update, and clear events. And the cockpit manager comes with 7 extensions that can be activated per system. I'll walk through the 7 extensions in a moment. So this is the picture we had. So now you can add some extensions that feed in messages to the agents. Okay. What are the 7 extensions? First of all, we do integrity hardware checks. OpenVMS comes with Intel's intelligent platform management interface. Well, it's an API that allows you to read the status of many hardware components in your integrity box. Okay. So we monitor temperature, ambient, internal, processor, DIMMs, I/O razor boards, power supplies. Oh, I need to go open pictures. Fan conditions, or fans at the right rotation speed. Power supply failures. Battery statuses. If somebody opens the chassis, we will see that. And if somebody takes out some hardware, we will see that as well. Okay, that's all done with an API which is available on OpenVMS. Second, we monitor the smart array controllers, the MSAs, 1000, 1500, 2000, 2040, 50, 60, the P400, P410i, P411, the P812. It's all basically everything you configure with MSA utility. Okay, so what we do is monitoring the controller status, the cache. Cache is very important. If your cache fails, for instance, because the battery is out, then your disks are really slow. Okay, if the cache is working, you have the best storage there is in the world, I think, with the MSA. Physical disk states, predictive errors, status of logical units, failed drives, activation of spare disks, everything is covered. Okay? Everything that can go wrong, you will get notification on this. There are 2 important hardware monitoring tools. Then we do the volume checker. We look for selected files if they not become too big. Log files grow like hell. Then sometimes it's useful to get a warning. They're a bit bigger. We look for files with high version numbers. In some cases, when you reach the maximum of 32767, your application stops working. That happens. We look for directories with large number of files. We look for the overall file count on a disk. Still people using disk quotas? There are still that I know. We identify the accounts nearing the quota limit or UICs that exceeded the quota limit. So there get also some information from. Don't ask me much on ACMS because I don't know the product. I never used it myself. But what we do basically is we take the output of ACMS show system and ACMS show application, and we check if the output matches what is expected, right? So is ACMS properly initiated? Are the applications started? Are all server processes present? Is there a pool available? Are there waiting tasks? And so on and so on. The fifth is the LAN device monitor. When you set up your system, you configure your network ports. All, some you don't use, depends. You set it up, and the settings must remain the same all the time. So we take a snapshot in a little file, and we compare every minute the actual settings, the current settings, with our snapshot. And especially we look for failover devices, and we check if both devices in a failover device are indeed active, so that failover can properly work. A bit similar is the fiber channel path monitor. I think it's a good practice to choose a dedicated path for each disk. It's up to you, but if you do so at startup time, you can easily check if your preferred path, your chosen path, is also the active path. If there was no switch, path switch. So the fiber channel path monitor checks if all paths to disks are available. If the current path is the preferred one, we also look for timeouts of the different paths. And we use the SDA fiber channel extension to read out the performance, and we look for slow IOs. And they're really slow. We don't put the limit very, very tight. And as such, we can gather some information on the DIO rate of the disk, and we can set that in graphing. This monitor is new. It's related to SCACP. We use SCACP to read out retransmit counters. So if you have cluster communication between two nodes in your cluster, it may happen that you send a packet to the other node, you wait for the acknowledge, that the acknowledge doesn't come back fast enough, and then you retransmit the package. Or sometimes you send a package and it's lost in the network. I recently had such a customer who moved one system to another data center, and suddenly the cluster was not performing anymore. And it was due to wrong SFPs in this network switch. Okay? These problems will appear when you run in such a situation. If you have a problem somewhere in your network, then you will see more retransmits. The cluster SPD specifies 1 packet per 1,000 packets may be lost or retransmitted. Okay. We also check cluster weights. There's a parameter cluster credits on sysgen, which defines the number of receiving cluster buffers. Of course, you don't want to put it to the maximum of 128 because it eats a bit of on-page pool. If you put it too low, you may run in waiting for a free buffer. And that costs you in your performance of the cluster again. According to the cluster manual, 1 per minute is still acceptable. And in certain conditions, a little bit more, but not too much more. Okay. So that's a new thing we will release next month in 9.2. That are my 7 extensions. And you're free to add more extensions. You develop them in DCL, you develop them in a high-level language, no problem. That's for the system monitor. Now the network and storage monitor. I told you we have today storage in the SAN, or storage behind the RAID controller. That's covered. The SAN is not yet fully covered. You build redundant configurations, but yeah, if you have one fault, one error, you continue, but you lost your redundancy. So we want to monitor a little bit more on storage. Network cluster is the network is the cluster interconnect. Problems with your network has impact on the cluster, and users can't reach the system maybe. So what can we do outside the VMS level? First thing you can do is to configure all your network and storage devices to send SNMP traps. Passive alerting, I mentioned before. What's an SNMP trap? It's a little binary package. Content is defined by the SNMP protocol and the MIP file that is used to implement the agent. Okay, the content, like for instance, if a port of a switch goes down for some reason, you will get a binary packet. If you decode it, that will say port that number is down. Okay. Is it already?
Wow, it was at the end.
Okay. So the traps are sent. It's UDP. The SNMP trap listener captures traps and converts them, decodes the binary package, and converts them to an event, to our 11 attributes. Okay. I think it doesn't cost anything to configure a device to send SNMP traps to the cockpit. There's always useful information in there. Now you say, do I have to be a MIP expert to configure all these traps? No, CockpitMgr comes with literally thousands of pre-configured traps for devices we see at all our customers: 3PAR, Primera, Elektra, even EVA. Hitachi storage, Brocade, Cisco SAN switches, Cisco catalysts. Okay. If you say, well, I have a special device and I don't know how to do it, we will help you, of course. We have tools to compile MIPS, and we can speed that up very, very quickly, the definition of SNMP traps. If you do the traps, you can also do the gets. You send an SNMP package to the server, to the device, also in a predefined format, and you get a response back. You say, give me status of port X, and you get the status back. Okay. What we did is we took the system monitor and extended it. Up till now, the system monitoring was monitoring VMS systems. Now we will add a blade enclosure, a Cisco switch, a Brocade switch, things like that. And the only thing you have to configure yourself is the host name, the list of the ports you want to monitor, and the credentials. It's community name if you use SNMP 1 or 2, username and password if you use SNMP 3, and you can also use encryption, privacy, in your trap, in your SNMP get. So you don't need any MIP knowledge to configure a Cisco switch, a Brocade switch, or whatever. You only need credentials, host name, and the ports. So we can extend our picture here. You can create a file with storage and start up a monitor for storage devices. You can mix them up. You can put a storage device with a VMS box, no problem. With SNMP, we monitor storage. You can create a config file for networking and start up a monitor for network devices and monitor these devices as well. SNMP, what we add to the product is driven by what customers use, what they demand from us. We support all 3 levels of SNMP, 1, 2, and 3, all 3 versions. We also created DCL commands, SNMP get, walk, set, and trap. That makes it easy to work with the node and do some tests and walks and see what is available and things like that. It's not an open source board, that SNMP stuff. We wrote it ourselves to keep maximum control on the sources and do something with the results we obtained from SNMP. I told you that we follow the trends, and this is a new trend that some devices implement a REST API, and that you can use curl to query with an HTTP request information from the device. Usually, you get the information back in JSON format. I call it a lightweighted form of XML. So we wrote our own parser for JSON buffers so that we can fetch exactly what we needed. And we do that for 3PAR, Primera, Alletra, Hitachi, and also for Synergy. It's nothing to do with VMS. We did that for one customer who really wanted to have more information on this Synergy on the cockpit. And then how I'm doing with the time. Is that normally the time for a break, or shall we continue? Nobody who needs urgent things to do outside. But I propose we continue. I'm more or less at the half, I think. So a few more modules for monitoring. There's a performance module. Now, don't think this is a replacement for E4 or Pervdat or policy and performance advisor and things like that. It's just a module that tries to find some causes of performance slowdowns, performance degradation. Like, suppose you usually use about 50% of the CPU capacity. If you're suddenly using for many minutes 90%, you like to know that, right? You want to take the triggers that you take a look. Can be normal. Somebody started a really big batch job. Can be normal. There's no panic. No panic is needed in this case, but it's useful to have a look and get a trigger to have a look. CPU, memory, utilization, pace and swap files, looping processes. We always say the process seems to be looping. Never say the process is looping. It's a process that uses the CPU. It's not doing any I/O. I'm sure there are scenarios where there are many I/Os and the process is looping anyway. But that's how we try to identify something that may go wrong. Even an idle process can be a problem in the system. Process in a special wait state, utilization of process codes, these things. Just alarming, triggering the system manager to have a look. Okay, we collect some performance metrics, limited, but we can present some graphs in a web interface. As I said, it's not an alternative for policy. Monitoring in real time of the security on your system. You depend on the audit server, right? For security, the audit server with us, all the alarming and all the work on notification. I explain. You know that, show audits. Okay? You have the alarms, you have the audits. What we put here now is, in the old digital times, we had to put on our systems. That was the minimum. We could do more, but that was the minimum. Never do enable everything, right? And it kills your system. You're in trouble, I tell you. That's a good start. What does the audit server do? It gets an event, security event. It will send it to OPCOM, and it will send it to the audit file. The audit file is easy to read with the analyze audit utility. Opcom, they send it to the console if the Opcom class security is enabled on the console. So what you get is blocks of data like this. Okay, I tried to log in from one system to another, and I specified the username that did not exist. I'll try to take that information and put it in my events block of 11 values. Bit of work. And do it in real time, it's really big bit of work. So what we do, forget the alarms. Disable all the alarms. We keep the auditing to the file. So that goes away, and that goes away. And instead, what do? We can instruct the audit server to write things to mailbox. That's the same binary record we write to Opcom or to the security audit file. And then we have a process that reads the mailbox, CPT security. All our processes start with CPT. Right. And we take that information and convert that to something like this. The virtual hidden failure detected, initiated by those who choose. That's a single line. It appears on the console manager captures it, and you have your event. Okay? That's for security, real-time monitoring of security events on your system. If you can scan the console for text strings and text patterns, you can also do that in a log file. Okay? So you can define log files to scan. You can define text patterns to scan. And you can use open files. So if people submit applications or patches, we start reading the log file. We reach the end. The file is still open. We keep the record file address of the last record. And in so many minutes later, we open the file again. We jump to that record file address. We continue scanning both. We do also environmental monitoring. In your data center, you have temperature and humidity sensors, power distribution units. Somebody pulls a plug somewhere, you know. Okay. Door sensors. I had a customer. He's located in Germany, but he has data centers all over Europe, and there are no system managers there. And if something fails, if some hardware problem, then he has to send over an HP engineer to solve it. Well, he had a problem in Paris in the data center, and the engineer said, yeah, I found the system, I'm going to switch it off on the phone to my customer. And the customer said, no, you won't, because you opened the wrong cabinet. I see what you opened. Okay, so it's useful. But our customers really want to see everything. They come up with such items. And then, yeah, I'm almost ashamed to mention this, but we also did something for our Unix friends and Windows friends. Okay, we developed a little Linux agent, limited functionality, processes, and 3 disk space, and the same mechanism to feed in message from your own scripts. Okay. For Windows, we didn't develop an agent. We use the SNMP agent of Windows. That allows you to monitor processes, services, disk space, CPU, and memory. We also have a syslog server based on VMS. So on Linux, it's quite normal that syslog messages, compare them a little bit to the operator log file, that syslog messages are forwarded to a syslog server. And of course, we also scan what we receive for dedicated strings patterns. For Windows, you can do that as well. There's some open source that allows you to forward the event log from Windows. Even a laptop sends a lot. Don't underestimate this, what you will put on the network. And then we are at the event engine. So we collect a lot of information with all these modules. We feed them in what we call the event engine. And there we prepare them for notification. So before sending things out, we can maybe change a few things. Or we can correlate events so that we avoid sending 2 events if you can limit yourself to 1. I give you an example of that in a moment. You can transform events. Suppose you receive an event with an error code in it. Then it may be useful to transform that error code to comprehensible text. You can avoid duplicates. You can start up automatic repairs. Okay, the processing, the preparing of the events is rule-based. With some simple rules, you can obtain very powerful results. An example. Suppose you scan on the console for the pattern device asterisk is offline. You get that message, device DSA1 is offline. That will be an event. Suppose you also scan for mount verification has completed for device DSA1. That means that your first problem is solved. It's solved on condition that DSA1, the device name, is the same as in the first. That's right. So the rule will be, if the system is the same and the subsystem is the same, 2 events can be correlated. So how do we proceed? That's our first message. That creates our event. You get the sequence number, you get the system. The console manager does not give subsystem. Something. You get a name, OpenVMS device offline, the class is OpenVMS, the text is device DSA1 is offline, and so on. Okay? As I said, system and the subsystem must be the same. So how do we get the subsystem in there? Subsystem will be DSA1, the item to which the problem relates. Okay? How do we do that? Well, we define in our event engine a rule. We say reprocess. If the name is OpenVMS device offline, the new subsystem will be between parentheses device 2. What does that mean? You look in your text for the word device. That's the first word. And then we take this 2, and that means it's the second word starting at device. So here we come with our DSA1. Similar thing for mount verification has completed. We should create an event. We didn't fill out a number yet, because what are we going to do? First of all, we have to fill out that subsystem. Similar thing, rule 2, reprocess, name, OpenVMS mount verification completed, new subsystem, device, now with lowercase, this device, and the second word counting from device. So there comes my DSA1. Everybody follows? And then the third rule, where we say correlate event name OpenVMS device offline, cleared by OpenVMS mount verification completed, and the solution is mount verification completed. So what happens in our first data structure? The priority becomes clear. The solution is filled out. And we drop that second event. It's gone. You won't see it anymore. Okay? Now I can do the real notification work. The event console is the first major way of sending events to somebody. I'm not going to read all the events. You can configure in that motive application the different fields, the 11 fields from an event. Usually I take system, date, time, the text, and the solution. There are some more you can activate. The color of the event corresponds to the severity or the priority of the events. So you have red messages, that's critical, magenta is major, and so on. So you have, for instance, here the process DB server is missing. That was originally a red event, critical event. Somebody started up the process, it became available, and the message turned green. In the same way as we had our disk is offline and mount verification completed. Here I have a number of buttons, and these buttons can be customized. You can say, if you click on one of the buttons, you can say, I take one, the system monitor, like system monitor. Then I only get the message that comes from system monitors. Okay, so I reduce, and it makes me more readable to say, okay, now I'm really checking what the system monitor told me. When you click on a button on the first row, it activates buttons on the second row. So you can say, give me the system problems. Give me the network problems. Give me the storage problems. Load them all again. Go back to the original view. You can delete events by double clicking. You can say delete cleared, delete sham. It's always for the selected event. Yeah. You keep them all, I do delete sham. Here everything will be gone. You cannot delete the message from the system. You have to solve the problems there first. But all the rest you can delete if you like. Okay with that? I think that's a powerful application that every system manager has to keep on his screen while doing his other work. So he keeps an eye on what's going on in his cockpit. We can also make it more fancy with a graphical user interface. This is the layout of a cluster, of multiple clusters, 3 clusters. We have 2 sites with production nodes and a quorum site. And in between we have the Cisco network. Okay. So everything is colored green, but everything is up. But sometimes get an icon in red. It's a cluster. You can click on that cluster and you see that shadow sets. Somewhere there's a problem with the shadow sets. And that one member has been removed from the house. That comes together with the message in the event console. There is a disk missing, it's member of shadow set. But this is nice to have somewhere on the wall. Be sure that everything is green, that everything is on. Sometimes you can click on like this is a fiber channel switch. You can click on it, you see all the sensors we are monitoring and the statuses of the fiber channel and the different ports we monitor for VMS. And if you put your mouse on one of the ports, then there's a little pop-up box with its port 16, and that goes to the FGA0 of that system. And this is another example where we put more focus on the SAN between 2 sites. It's a site between Brussels and Antwerp. In bird's flight, it's about 60 kilometers. And there are 4 paths to the 2 sites between 60 and 360 kilometers. So it's important that you use the shortest link to the 2 sites for your I/O, for your bytes at least. Okay, and then text messaging. We use various methods for texting to your cell phone. Some providers support that you send a mail with a cell phone number and a text, and the provider sends it on the network. For our US customers, we implemented WCTP and SNTP protocol to communicate to the providers. The easiest way is the cellular engine. Okay. In CockpitMgr, you can say who should receive what and when. If you have two applications and two application managers, message related to application one should only go to that correct application manager, right? There's also a possibility to set up a duty schedule so that you define who is on duties and when you can change that dynamically. Okay, the cellular engine we used during a long time, something from Siemens. It's a little box, but it needed a serial cable to a COM port on your integrity or to DEC server. Reliable, but slow. Okay, so you just put in a SIM card, you find the right cable to connect your device, you need an antenna, and you can send text messages. A much nicer device is the SMS Eagle. It's a networking box connected somewhere on your network, just to keep that cable you need. You can send up to 30 SMS per minute. It also needs the SIM card, of course, and it's easy to set up with a web browser. It's very small. Looks big, but very little. And then there is also a web interface. You can display your events per group, per class. You can delete events. You can watch some performance graphs. You can browse console logs. You can do event reporting. On configuration management, I come back later on. You can watch your environment, temperatures, humidity in the computer rooms, and so on and so on. So if you click on all events, you get the same message as you had in the event console. It's one main difference. We are in reverse order. The most recent one is here on top. The event console, it's on the back, on the bottom. Okay. Just to mention this one, if you have a disaster-prone environment, you cannot live with functionality of one something in one data center. To lose that data center, you're lost. Okay, you need actually a cockpit in both sides. You have a cockpit active and a standby cockpit. They are sending heartbeats to each other. So as soon as the heartbeat is not arriving, the other one will start up. You can do manual switchover, and all events detected in the primary cockpit are also copied to the standby. So you have always a reasonable log of the last events when you lose your primary cockpit. Shall we do a quick recap on the whole cockpit? Monitoring and notification. Okay. Cockpit manager in one slide. What do I have in my computer center? Integrity servers, plates. Maybe some alphas, right? If you are clever, you move these alphas out of your data center and replace them with an emulator from APT or from Carbon. Or if you're really, really clever, you move your VMS systems from Integrity to VMware, for instance, with x86 ESR. Okay. What else do we have in the computer room? Network switches, storage. And all this we're going to monitor with a cockpit. Cockpit runs on OpenVMS. Right? First module we've seen is the system monitor. do we need? Thermal server for the alphas, for the network, for the storage devices. Optional. Okay. For the integrity and the blades, we have the management processor, and for the ProLines, we have an IP port. Console manager connects to these and scans the events that are sent to the consoles. Second module, the system monitor, talking to an agent. And next to the agent, we have a performance agent, security agent, hardware monitor, log file browser, RAM monitor. And I'm running out of space on this slide, couldn't put everything on. Okay. For network and storage, we have an SNMP trap listener. Network and storage are sending traps, and I push too quickly. And the system monitor has been extended to do more than just VMS systems. They do SNMP gets to these devices. Notification through an event console, GUI, a web browser, and a cell phone. That's in a nutshell what we've seen in 64 slides. Okay. Integration. Okay. People say, but I need to send my events to something else. And so we do that as well. The easiest one is sending SNMP traps. That works for everything. The work needs to be done on that something else. I have here a screen capture. It's more than 20 years old. It's OpenView running on HP UX. Okay, that's what I call the message browser. I did some experimental work at the time with that. So I have the same events in my cockpit, and with SNMP traps, I'm sending them to OpenView. OpenView can be anything with a trap listener. I have customers using Netcool or Nagios, and they receive the traps. They display the events in these products. That's the easy bit. You can say which events you want to upload. What you see more and more today in the field is ServiceNow. ServiceNow is the playground of operational management. They use it for events, incidents, problems, and change and everything. Don't ask me nasty questions on ServiceNow, but we can upload automatically events, or we can select them. And go back to my event console. Now I enabled also the owner field. Okay. I come back to that message with my database server is missing. It was actually noticed by the automatic repair, the autopilot, that he could start up the process. So he did. He took ownership on the event. He started up the process. The message became red. From red it became green. Okay. Now I have here a message: process DCI to cloud out by 120,100 is missing. You as a poor system manager can say now, I try to start it up, it fails, I need more help, I have to escalate. Instead of calling somebody, you click with your right mouse button on the events. You go to the end of the menu that pops up and it mentions send to ServiceNow. And when that succeeds, the message field, the owner field, is filled out with ServiceNow. Okay? And if you're watching ServiceNow, you see that thing, that message in the event, in the alert table. If you double click on that one, you see a screen with the details of that event having occupied. Right? Something similar for Zabbix. That's also something you see more and more in the field. Zabbix is an open source software tool for monitoring IT infrastructure. Okay? Again, you can configure uploads of events to Zabbix. And there you see the same message. It's over here. And this is the enlargement of that event. Major difference. In the cockpit, it's a critical event. Here, it's a disaster. Wasn't it? Then a few more utilities. We start with the job scheduler. Yeah.
Should we just mention that we also get the acknowledge from Savix that the has been received to the Savix server?
It's in the log file, but it's not because Zabbix, I only implemented the automatic upload, not the manual thing in the pop-up menu. Can be done. It's not an issue, but I only implemented the automatic upload.
Yeah, but when we send the messages to Savix, we also need to get the acknowledge, because if anyone says, why didn't we get this message? Yeah, we have sent it.
Okay, I can add it.
No,
like
but
that.
you have.
It's easy. Yeah,
Yeah,
only
but you
software.
have, but you have already added it. We have it.
Yeah, but I don't put it in the event console.
No.
I don't change the outer field for Zabbix.
No. But we get it in a log file.
Yeah, you have it in the log file.
Yeah.
Okay, the job scheduler, census, configuration, change management, then DCL, and then backup, which is new. The job scheduler, I usually say scheduler, but somebody told me once scheduler. Okay. That was not on the list of things to do back in the 90s. Okay, but we did the migration at one customer from VAX to Alpha. And 2 days before to go live on Alpha, that customer said, oops, we still use Polycenter scheduler on VAX. I don't have any money left for a scheduler on integrity. My response was, okay, I'll write you one. It's the same thing as Polycenter. The only thing what we don't have is the motive interface, the running man, if you know what I mean. So why do we develop a scheduler? You can say I create a job in a batch queue, and when it's terminated, I calculate the time for my next run and I submit it again. And you have to add notifications, start the job, end the job. If the job is submitted and you want to make a change to the DCL, you have to delete it and resubmit it. It's quite clumsy. Okay, so we want everything which is not really the meaning of your job out and give it to the scheduler itself. So you can submit things hourly, daily, weekly, monthly, on an interval basis. You can say the last Sunday of the month, the first Monday of the month, you can do that. You can run it on specific days of the week, only on Monday, not on the other days. You can all do that. And you can create job trees. That one job is started when other jobs complete successfully. Here's a small example. We have this little chain. It's the end of month. It runs every last Sunday of the month at 2 o'clock. Right. Okay. End of month completes. Payment, cash flow, and balance starts. Payments and cash flow complete successfully. Profit loss starts. And then at the end, after balance and profit loss, the end of month summary starts. For the event console, I selected operations and then scheduler. So I only see messages from the scheduler. So it starts 2 o'clock, 27th of April. You can check, it's the last Sunday of the month. Started, the job completes, 3 other jobs start. Balance completes, payments completes, cash flow completes, profit loss starts, completes as well. And now profit loss is finished and balance is finished. End of month summary starts and completes. So you always have a good view what is running on my systems. You're not always that lucky. Make permanently an error. So you do some work, you correct the mistake, you resubmit. 2 messages turn green because it's job restarted, job starts, and the job completes. Okay? No questions? Sensors, configuration and change management. We scan VMS systems, we scan Brocade fiber channel switches, Cisco, catalysts, Nexuses, storage arrays, blade enclosures, virtual connect modules. And we collect everything we can find, configuration information. We save that data in XML format. That makes it very flexible to store things. Each time we save an XML file, we compare it to the previous version. We generate a report on VMS. This system parameter has changed. This user has been added. This quota has been changed. This disk has been added, and so on and so on. You see clear change, a report on all changes on your system. Then we use XSLT to display the XML data. Show you an example in a moment. We also correlate information. For instance, you can find easily to which port an HPA port is connected, which port of a switch. We also implemented Cisco Discovery Protocol on VMS, so it's also possible to detect on which the catalyst port, which system and which network interconnect port is connected. Okay, I'll give you an example. We select a system to check the information we collected. The first screen gives you data on the node name, the hardware type, the CPU's hyperthreading enabled or disabled, the serial number, the last boot time, and so on and so on. Okay. And then you have a number of buttons you can select and see more information. For instance, if I click on controllers, then you see all the controllers in my system, and you see that FGA is connected to this fiber channel switch port 68. Can be useful, I think. You can do the same thing with Cisco. Okay, so you can also add your customer data. You can say, oh, that's my asset number in the company, that's the location, that's the contact if there's a problem, and things like that. You can do that. That's for configuration and change management. Census. Census is actually a Latin word used by the old Romans. And they kept a list of the population, and they indicated some characteristics on everybody. The main characteristic was that young guy is old enough now to go to the army. That was census, the list of the population. NetDCL. You're on your cockpit and you like to check something very quickly on a remote system. NetDCL, the node name of that system, show system, and you get it immediately on your display. It's well protected. It's well protected. Don't worry, it's really from somebody on the cockpit with a system account who can check his other systems he need to monitor. You can also use NetDCL for multiple commands. And you say NetDCL and a node name, and then you can give multiple commands, like here I do 2 lexical functions, and I write the output in a string to the output. So you work in the same process context on the other system. And when you exit from it, you have a symbol defined, netDCL, $netDCL, with the last line in. So you can use that in procedures. Makes it handy once in a while. And then we are at backup. That's the latest new module. We're still working on it. It's not 100% finished, but I can show you something. I have prepared a little movie with a demo. And we're still on time. Okay, fine. So what do we see with our customers? Well, some still use tapes and tape libraries. It's fine, but you have to think further. What we also see at many of our customers are enterprise client server solutions. What we see is something like store server, archive, and backup client. I heard it's a good product. It used to be integrated with Tivoli Storage Manager of IBM. That's called now IBM Data Protect, right? Something like that. But in the meantime, they also developed some other solution that you don't need Tivoli or that IBM Data Protecting, where it goes to another box where they store data, okay, from VMS. Legato is still in business. I don't have any indication that Legato will report to x86. They might do it. I don't think it's a problem to port it to x86. Commvault, I recently talked to some support people at Commvault. They will look into it for the future on x86. Veritas Net Backup is done. The old client does not work with the new server. So there's no more support for that anymore. So that's finished. Data Protector used to be from HP, went now to a company called OpenText. I tried to find out what their plans are. I run into a system of AI that tries to answer your questions. And I really didn't get anything useful back. So, okay, what do we see with many customers? They make a backup on disk themselves on a VMS disk. They create a safe set, and then they use FTP or SFTP to upload it to a Windows or Linux box, and from there they use the enterprise backup solution to put it wherever they want to put it. There are drawbacks, several steps, time consuming. It requires temporary disk space on VMS. And if you like to restore a file from a safe set, you need to download the entire safe set and extract it from the safe set. We thought by ourselves we can do better. Okay. So, what did we do? We skip the local safe set, we skip the FTP, we back up directly to Windows, Linux, or VMS. VMS, you will say, no big deal, I can use backup for that. We don't use, I use DECnet for that. We don't use DECnet. We use IP. You go to OpenVMS, Windows, or Linux directly, and the result is a real, valid VMS safe set. Okay? You look for it.
No, happy.
Okay? So, from there you can use the enterprise solution. But now, suppose you like to restore one file from the safe set. You can do that without restoring the safe set first entirely on VMS. That's interesting, right? And it's all managed from VMS. So that's the picture. Backup servers, 3 platforms, Windows, Linux, and OpenVMS. There is some little software running, backup server software. The one on Linux and OpenVMS is as good as identical. I could port that to Linux. The one of Windows has been ported by one of my colleagues who knows Windows a little bit better than I do. So on VMS, you have the command make backup. You can choose between an image backup, an incremental backup, or a backup of a directory tree. And we have also command fetch backup that restores you one file. You can select which version you want to restore. We will add now also the directory tree, let's say, or the full restore of the save set, if you like. If you can do one, you can do them all. Okay. So, Oliver, I think I need you now for a little demo. So that's my setup. Oh, okay.
Sorry.
Okay, no problem. I can tell it like this. I have at home an old RX 2620 office friendly server with slow disks. There is no cache or whatever or RAID controller. I created an LDA device with 3 gig, and I have my old Windows 10 laptop wired in my network. Okay, now we can do the movie. And if I say, Oliver,
Yes.
stop it once. If the movie moves faster than I can talk, then will you be prepared to
I will.
the button?
I will.
So what I have here is my Windows system with 3 directories. It's running already, yeah? Right?
Yes.
There's a backup directory where I will put my save sets. There is a log directory with log files, and there is a x86 directory with an image. Yeah. Let it go. Let it go. So it's backup server exe. I started up in a PowerShell. I have to give 2 parameters. That's the port on which I'm going to work, IP port, and the directory where I'm going to put the save sets. Okay, that's all. Starts on VMS. I need some parameters. There is a cockpit utility with parameters, and I check my cluster name, my server name, that's my PC, and the port is the same port I'm going to use. And if I look at LDA1, you see I have a device with 7 million blocks. It's almost fully filled up. And now I create in my own directory a little file with 1 line. Okay. Tell you why in a moment. I create a second file and I leave it open. So you can imagine that the backup will create some messages that look familiar. File is currently open for write. And I create a third file which I put on no backup. So it will say file is marked no backup during the backup. I start up my make backup. I do LDA1. I do it /image/record pass, and that's it. You will see here that in the backup there is a log file, and in the directory I'm creating a save set, and you see that the size goes up the time. So over here you see image backup started. I'm using this socket. That's my save set name, my backup listing, and I have 2 warnings. There is a file data not copied because it's marked no backup, and there is one which is blocked by another user. Okay, it will take 1 minute, and sometimes 1 minute is very long during a demo.
Microsoft minute.
Yeah. So you see that it will complete. The funny thing, the record pass will take longer than the backup in this case, because I have a slow disk on VMS. It has to open each file, write the record date, the backup date, and it will take a while. So that started. The file is there, 3.4 gig. Okay. Saves it closed. And now we have to wait really a full minute to finish the record pass. Somebody has a question in the meantime.
So would that work for a NAS, the NFS? Yeah.
Why not? It will be slow,
Because I
it
thought
will work.
you need a service for this to
You need what?
service running, like
You need some capacity somewhere.
no, I mean the backup server you started from Windows, right?
Yeah, in this case it's Windows, but it can be Linux. Okay, done. You see, 61 seconds for the backup, 77 for the record pass. It worked at 50 megabytes per second. I've seen better results, but with fiber channel and a good server and a good network. So in the meantime, I appended a line to my file test1. And now I'm going to make an incremental backup. And you know, with incremental backups, it backups what is new or updated, plus all the directories of the disk. So there we go. 2 seconds and 4 seconds for the record pass. I did the logging, just do one file and all the directories, which I don't put in my log file. Got now 2 save sets. An image backup and an incremental backup, right? I delete my test1. I will try to restore it. Patch backup, LDA1. I specify file the test1.txt. Could have specified the directory, but I didn't do that. I get 3 results. First one is in the incremental, that's the most recent version. The second one is in the image backup, and the third one is in a completely other directory, which I really don't need. Okay, so I selected 2. The file is there. 0 seconds. It's my first version bit. This is my first line. If I take the interactive away, it will restore the most recent version, also 0 seconds, and this is one with 2 lines text, the updated one. What do you think, Duncan?
That's good. Would it work with data compression?
I'm going to be careful. I think yes, but I didn't test it yet. I made my tests quite recently with encryption. That worked. So I expect that data compression will work as well. Okay. We release next month the latest version with the first version of backup in there. This is the first release where we don't support anymore HPVMS for the cockpit. For all the rest, we support whatever runs VMS. For the cockpit, we really force you to VSI VMS with the VSI TCP/IP version 6 and OpenSSH. We don't want to continue anymore with the old SSH. It's really time that everybody moves to the new OpenSSH, I think. For the managed systems, we go back to the VAX, the alpha. We don't do VAX alpha 6.0 and 6.1. There were too many implementations in the CRTL, so it's starting at 6.2. Integrity x86. I think we were one of the first applications running on x86. I think it was 21 when we built the first version of CockpitMgr on x86 with the cross compilers. No issues. The only work we had is in our build procedures. We suddenly had to install 4 platforms instead of 3, and different versions of SSL, and so on and so on. So it was more if then else all the time in the build procedures than changing software. We virtually didn't have to change anything in the software. Straight on. And I'm convinced that moving to x86 will not be a big deal for most applications. That's my presentation. I didn't expect to be just before the end of the time. So questions, remarks? Do you think there is something better on the market?
I have a question. I saw yesterday's Heinz presentation of RMS and his tool for hot files. And he mentioned it's easy to export to T4. That be possible to implement it also in cockpit performance graphs.
Yes, it's possible. If you really want some, you can take the output of show memory / cache. There you find hot files at this moment. You have to build up some intelligence around it. That it's not because one file is a bit hot during a few seconds that you really want an alarm on it. I've been playing in the past with hot files, yeah. If you want something like this, it will be the result from show memory / cache. I'm not going in kernel mode to find out the hot files. Nowhere I'm using change mode to kernel in this. Right? So the risk that something will crash, the application may crash maybe, but not your system. Won't be work. Okay. Yeah, hot files, we can discuss this.
Unless it's
You need it
adding too much overhead.
by tomorrow, by yesterday.
No. It can wait. It can wait version 9.3.
We will discuss this. Okay. Anything else? No? Okay, no, thank you very much.
Thank you very much.